The focus of this video will be to define what a type 3 binary non-acid covalent compound is. Furthermore, I'm going to work multiple problems going from formula to name. Let us start by looking at some of the important rules when it comes to type 3 compounds. Type 3 compounds are usually formed between two nonmetals and are named using prefixes. The prefixes indicate the number of atoms shown by the subscripts in the chemical formula. The prefix mono is 1, di is 2, tri is 3, tetra is 4, penta is 5, hexa is 6, hepta is 7, octa is 8, nona is 9, and deca is 10. Another important thing to consider is that whenever you're going from name to formula, to not use the prefix mono on the first element. And if you have AO or OO, you need to turn it into just O. And we will look at examples with this rule. So as mentioned previously, a type 3 compound is usually composed of two different nonmetals. And those nonmetal atoms share electrons. The nonmetals that make type 3 are found here in the yellow area. Remember that type 3, you have to use prefixes when writing the chemical name. And the prefixes equal the subscripts in the chemical formula. And those subscripts represent the number of atoms that compound has. Looking at the overall, type 1 has a fixed charge cation. A type 2 also has a cation, but with multiple charges. And a type 3 consists of two different nonmetals, such as the example that we have here at the top, sulfur dioxide. By looking at this model, we can see how the subscripts within the chemical formula represent the number of atoms in this module. In between the C and the O, there's a 1 understood, so therefore, there's only one carbon atom in the compound. To the far right, there is a subscript of 2, meaning there are 2 oxygen atoms. Let us go from the chemical formula to its chemical name. So the first step, like we have been doing in the other type of compounds, is to name the first element or polyatomic ion. I know I see the element of carbon. Next is to name the second element or polyatomic ion. And if it's an element, we need to change the ending to IDE. So instead of saying oxygen, it's going to say oxide. Now we need to determine whether this compound is a type 1, type 2, or type 3. I see 2 nonmetals, so that's going to make it a type 3. And you can find it here as well in the yellow region, carbon and oxygen. Now, for each element, we need to use the correct prefixes based on the subscripts of the chemical formula. In the middle here there's technically a 1 understood. And the number 1 is represented by the prefix mono. The rule, however, says that the first element cannot have the prefix of the word mono. So it's just going to stay as carbon. To the right side of the oxygen, there's also a 1 understood there. And remember that the number 1, its prefix is going to be the word mono. However, whenever we add the prefix mono, we now have 2 O's. And you cannot have that either. You cannot have two O's, nor can you have a O. You have to change it to O, to just one single O. So that would be carbon monoxide as its chemical name. All right, we now have this chemical formula. We need to find its chemical name. The first step is to name the first element, and I see chlorine. The second step is to name the second element and change its N into IDE. So that would be oxide. Now we need to determine whether the compound is a type 1, a type 2, or a type 3. And that is definitely a type 3 because I see two nonmetals, and I can confirm it here. I have chlorine and I have oxygen. Now, for each element, we need to use the correct prefixes based on the subscripts of the chemical formula. The number 2 is represented with the prefix di. So dichlorine so far. And the number 7 is represented by the prefix hepta. However, when I do that, it presents a problem. Why? Because you cannot have an A and an O side by side. So you're going to have to remove the A, and the final chemical name is going to read dichlorine heptoxide. Okay, so now we have this chemical formula. Remember that the first step is to name the first element, which is sulfur. The second step is to name the second element, but change the N into IDE. So that's going to read fluoride. Then we need to determine whether this is a type 1, a type 2, or a type 3. I know this is a type 3. Why? Because I'm seeing two nonmetals and because I can find sulfur and fluorine on the right side of the periodic table. Now for each element, we need to use the correct prefixes based on the subscripts of the chemical formula. There's technically a 1 understood here. However, the first element cannot have the prefix mono, so we're going to have to leave it as sulfur. I'm seeing a 6. Therefore, the number 6 is being represented by the prefix hexa. So I'm going to have the whole chemical name reading sulfur hexafluoride. All right, so now we have this chemical formula. We start by naming the first element, which is nitrogen. Now we name the second element and change its N into IDE. That would be oxide. We now need to determine whether this compound is a type 1, type 2, or a type 3. I know it's a type 3. Why? Because we have two nonmetals. Now, for each element, we need to use the correct prefixes based on the subscripts of the chemical formula. I see a subscript of 2, and the subscript of 2 is being represented by the prefix di. So now we're going to have dinitrogen. To the right side of the oxygen, there is a 1 understood. So the number 1 is represented by the prefix mono. Our entire chemical name is going to read dinitrogen monoxide.